Here we're going to look at what it means to use combinations in order to calculate the number of ways you could order something, the number of possible ways you could order it. Now, in these cases, combinations are talking about the idea when order is not important. So for this, we have a very specific formula. So in this case, we would have NCR, where C stands for combination. And here we would have n factorial over r factorial times n minus r factorial. Here, my n is going to be the number of objects that I have, and r is going to be the number chosen. Now, it's very similar to a permutation, but again, the biggest difference here is that the order in which we choose an object does not matter. So for the first one, I've got a couple examples. So here we're looking at 12 choose 5. Okay. So here this 12 is going to be my n, and my 5 here is going to be the r. So I would put things into my formula the way they're meant to be. So this would be 12 factorial over 5 factorial times 12 minus 5 and factorial. And from here you would simply reduce that down or solve it. So in this case we would have 12 factorial over 5 factorial, 7 factorial. So this would change to be 12 times 11 times 10 times 9 times 8 times 7 factorial all over 5 times 4 times 3 times 2 times 1 times 7 factorial. So you can see my 7 factorials would cancel. This is what you were left with. When you multiply all that out, you're going to end up with 792. So that's going to be the number of ways in which you could choose 5 objects out of 12 total. Now if you look at the second example here, notice I have a permutation and a combination. So the biggest thing that you want to take note of is that you are going to solve these separately, then combine. So what that means is that the first thing we're going to look at is 5 permutation 3, which is going to be 5 factorial over 5 minus 3 factorial, which is going to end up giving me 60 as a result. Now the second piece we would look at is 5 choose 3 using our combinations formula. So 5 factorial over 3 factorial times 5 minus 3 factorial, and in this case we would end up with 10. So when we put it all together, we would have my permutation divided by my combination. So this is going to be 60 over my 10, which is going to give me 6. So that's why you want to solve them separately before you put them together. Now the next thing that I wanted to spend some time looking at was how exactly we are going to work with applications. Now with most of these applications, you have to determine what has to be used to solve the problem. In other words, you are not going to be told flat out if you have a combination, permutation, or just simply the fundamental counting principle. So here you have to be able to read it and look for clues. So the first one says we have 10 board members on the Community Arts Council, and how many ways can a president and a treasurer be chosen? Assume that no member can hold both positions at the same time. So in this case, the last sentence here, assume that no member can hold both positions at the same time, This is actually really important. This tells us that order matters. By definition, since order matters, this is going to be a permutation. So what do we have? My n is going to be the number I have to choose from, or the number of my members. In this case, 10. My r is going to be the number chosen. In this case, we're choosing 2. So here we would have 10 permutating 2. So that's going to give me my 10 factorial over 10 minus 2 factorial. In this case, we end up with my 10 factorial over 8 factorial, which is going to reduce to 90 ways. All right, let's look at the next one. I have 5 singers are to perform on a weekend evening at a nightclub. How many different ways are there to schedule their appearance? Well, this is just simply the fundamental counting principle. So for example, I have 5 singers, so that's just simply 5 factorial. What that means is essentially we are looking at how many ways can we schedule their appearance. So we would have 1, 2, 3, 4, 5 different ways. So for my first slot, we would have 5 performers to choose from. Once you pick the first slot, my second slot only has 4. My third slot has 3, my second slot has 2, and then obviously the one left over. So if you look very closely, this idea is that fundamental counting principle. So here we would have that there were 120 ways in which that you could order your singers. Alright, if Elliot has to submit 3 photographs for a school art show, this semester he has taken 29 photos that he thinks are show worthy. How many ways can he choose the photographs to submit? So in this case, we have that order does not matter. By definition, that means a combination. And that being said, my n is going to be the 29 photos that I have, with my r being the 3 I have to choose. So in this case, I'm going to have 29 choose 3, which is going to be 29 factorial over 3 factorial times 29 minus 3 factorial. This is going to be the same as my 29 factorial over 3 factorial 26 factorial, which is going to come out to being 3,654 ways to choose your photographs. A medical researcher needs 6 people to test the effectiveness of an experimental drug. If 13 people have volunteered for the test, in how many ways can 6 people be selected? So again, this is going to be a combination, because the order in which you select a person for the test does not matter. My n is going to be the total of my volunteers, so I have 13. My r is going to be the number I'm choosing, which is 6. So here I'm going to have 13 choose 6. So this is my 13 factorial over 6 factorial times 13 minus 6 factorial. To finish out the math, you would have 13 factorial over 6 factorial times 7 factorial. And in this case, this would give you 1,716 ways to choose your volunteers. Okay, let's look at another one. 50 people purchase a raffle ticket. 3 winning tickets are selected at random. If each prize is $500, in how many different ways can the prizes be awarded? So this is also going to be a combination, in that all prizes are the same, therefore the order of the prizes being given out does not matter. My N is going to be the 50 people I'm choosing from, and my R is I'm only choosing 3. So this is going to be 50 choose 3. So I'm going to have 50 factorial over 3 factorial times 50 minus 3 factorial. In this case, this is 50 factorial over 3 factorial times 47 factorial, which is going to give me 19,600 ways. Alright, let's look at just a couple more here. So the first one says, in how many ways can the letters in the word instructor be arranged? So this is called a repeated permutation. So a repeated permutation essentially says we need to know first how many letters we have. So my N is going to be the number of letters in my word. So if you count them up, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then we want to look at each letter being counted only once. So I have instructor, so I-N-S-T-R-U-C. T has already been counted. And then I have an O and an R has already been counted. So if I'm looking at my word instructor, I need to look at how many times each letter is counted. So I have 1, 1, 1, 2 T's, 2 R's, 1 U, 1 C, and 1 O. So the way that we write a repeated permutation is we have n factorial on the top, and then we have our repeated numbers on the bottom, and you keep going. So in this case, I'm going to have 10 factorial on the top, and then I'm going to have, and I'm going to list them out, so this is going to be 1 factorial times 1 factorial times 1 factorial, with a 2 factorial, a 2 factorial, and then 1 factorial, 1 factorial, 1 factorial. So if you think about this, dividing by the ones I can ignore. So this is going to be the same as 10 factorial over 2 factorial, 2 factorial, which in this case is going to be the same as 10 factorial over 4, which is going to give me 907,200 ways that I can reorder the letters in the word instructor. Last but not least, in how many different committees can be formed from 5 professors and 15 students if each committee is made up of 2 professors and 10 students? So the first thing I need to look at is my professors. And so here I have 5 choose 2. So this is going to be 5 factorial over 2 factorial times 5 minus 2 factorial, which is going to give me 10 as a result. I then have to look at your students, which in this case, this is 15 students choose 10. So this is going to be 15 factorial over 10 factorial times 15 minus 10 factorial, which is going to give me 3003. So in order to find my total possible, I have to take my professors and multiply that by my students. So in this case, I have 10 times 3003. So this is going to give me 30,030 ways that I could create committees. So there you have it, everything that you would need to know to be able to get started with and or use combinations. So if you have any questions, please let me know. Otherwise, I do hope you enjoyed this video, and I'll see you next time.